Hello everyone, welcome back to the channel. Today we are going to take a look at this question called Frog 2 from the Atcoder uh, DP tasks. If you haven't already watched Frog 1, please go and watch that. This is the extension of the Frog 1 problem. So I'll leave you the link to that Frog 1 question video in the description. Make sure to check it out. And this frog 2 question states that there are n stones numbered from 1 to n. For each I 1 less than or equal to I less than or equal to n means for every index the height of stone I is hi. There is a frog who is initially on stone 1. He will repeat the following action some number of times to reach stone n. If the frog is currently on stone I, jump to one of the following stone I plus 1, I plus 2, so on up to I plus k. Here, a cost of mod of hi minus hj is incurred, where j is the stone to land on. Then we have to find minimum possible total cost incurred before the frog reaches stone n. So, in frog 1 question, I can show you. In frog 1 question, n, no, not n, k was 2. So in this question, our k is given as some variable, but in frog 1 question, k was 2. So what we did is that for that question, I can show you. See, if you haven't watched already this frog 1 question, so please watch it before you come to frog 2. So basically it is the question related to dynamic programming, where in frog 1 we discussed that when k is equal to 2, to jump to the ith stone, frog will jump from I minus first stone or the I minus second stone. Okay, if it jumps from here or it jumps from here, suppose solve of I returns the minimum cost incurred to come to the ith stone, which will be minimum of solve of I minus 1 plus V of I minus V of I minus 1. V is just height array, absolute value of v of I minus v of I minus 1, comma, second argument will be solve of I minus 2 plus absolute of v of I minus 2. So for frog 1, this approach was used. So for frog 2, what we can do is that we will take, see, this is the ith stone, this is the I minus 2th stone, this is the I minus 1 first stone, you can call it I minus first, I minus second stone, and so on up to what, I minus kth stone maybe. Yeah, so I minus kth stone. So we can do solve of I is equal to minimum of solve of I minus 1 plus sum this value, comma, solve of I minus 2 plus sum this value, and I minus 3, so on up to I minus k, then we'll get our answer. So that is the only extra thing we have to do in this frog 2 question, which is nicely done. I'll show you here. So taking a look at here, just input, see how input changes, n and k, see n and k, and finally taking height array as input, then input is completed, and filling the dp array with some sentinel value as minus 493. We will use dp to the memo, dp to memorize the answers. So finally dp of 0 will be initialized to 0 because we are already on stone 1. Okay, so we don't need to incur any cost to go to stone 1 itself. And then finally calling solve of n minus 1 dp of v in frog 1. Second, and solve of n minus dp comma v in frog 2 question as well. So I'm keeping this k as global so that I could use it in solve function without passing it as an argument to the solve function. So if I is equal to 0, return 0. We saw that dp of 0 is 0. Otherwise, if dp of I is calculated, dp of I is not minus 493, then simply return dp of I. Then cost to reach to the ith stone is initialized to L long max, which is the maximum value that long variable can take. And then finally, this is this is the check to go inside this function solve of I minus j. And yes, finally we'll do cost of minimum of cost comma this thing for all j is equal to 1 to k. And finally we will update the dp of I with the cost, means memorize the answer and return it. So finally our solve of n minus 1 will give us the answer to reach the nth stone. Solve of n minus 1 will give answer to reach nth stone because I am using zero based indexing, so that's why. And yes, you can try to dry run this code on some sample inputs and you'll see how is it working. So yeah, that was it. So this was the question for today. And second question from our Atcoder DP solutions. I am hoping to cover all the problems from this DP educational contest from Atcoder. We have 26 problems. I have personally solved till I think so. I'll be solving all of these and posting it on our channel. So stay tuned. Thank you for watching the video. Consider liking the video, subscribing to the channel. I hope I'll see you again seeing my videos, watching my videos. So yeah, thank you.